Hello again, Math 10Cs. In today's lesson, we're going to begin the first half of the final lesson in the course, which is just a continuation of dealing with word problems where we're going to have to set up a system of equations to solve. So today's lesson will look at mixture problems, and then in the next lesson and the very final one, we'll look at some distance problems. So let's jump straight into this. Cashew nuts cost $22 per kilogram. That's your unit price. And they are mixed with Brazil nuts, which cost $16 per kilogram. The mixture weighs 50 kilograms and sells for $18 per kilogram. How many kilograms of each type of nut were used in the mixture? Okay, so the different types of nuts we have here are cashew and we have Brazil. The first thing you want to do in these word problems is you need to pick two variables that are going to identify the two things you don't know. And the two things I don't know here are the mass of the cashew nuts and the mass of the Brazil nuts. So I'll start off by identifying those variables. So we'll let X be the mass of the cashew nuts and mass, and this problem is going to be in kilograms. And then we'll say let Y be the mass of Brazil nuts. Also in kilograms. Okay, now it tells me that the total weight of this mixture is 50 kilograms. So the first equation is pretty easy to write down. So if you take the mass of the cashew nuts and add it to the mass of the Brazil nuts, that must be equal to 50. So it'd be, I'll even write this down here. We'll say my mass equation. So your mass equation would be X, the number of cashew nuts, plus Y, the number of Brazil nuts, would be equal to 50. So let's box that equation, and we'll call it equation number 1. The second equation I want to write down is going to be for the total price of like the mixture and also the price of the cashew nuts and the Brazil nuts put together. So the first thing I want to do is I want to figure out what the total cost would be. So I'm going to look at this sentence to identify the total cost. If the mixture weighs 50 kilograms and the unit price is $18 per kilogram, the way I would get the total price is I just multiply these two numbers together, the 50 kilograms and the $18 per kilogram. So we're going to identify that as being my total price of your mixture. And that total price would be 50 kilograms multiplied by $18 per kilogram. I should just point out, if you multiply these two together, these units actually are going to cancel off because you have a kilograms on the top here and a kilograms on the bottom. So if you have the same unit on the numerator and denominator, they cancel off. Therefore, I just multiply 50 by 18, and then 50 by 18 would give me 900. Now, I want to write down the price equation. So first of all, I want to identify what would be the total price just for the cashew nuts. Well, to do that, you would take the mass of the cashew nuts, which is X, and multiply by the unit price. So that would be X times 22, or 22x. Okay, we're going to write down the numerical coefficient first. So 22x would be $22 per kilogram multiplied by whatever the mass of the cashew nuts is. We don't know that yet. Okay, I'm going to add the total price of the Brazil nuts. So the Brazil nuts would be $16 per kilogram multiplied by the mass of the Brazil nuts. So that would be 16 multiplied by y. If you take the mass of the cashew nuts and multiply by the unit price of the cashew nuts, add the mass of the Brazil nuts, multiply by the unit price of the Brazil nuts, that's going to be equal to 900. And that's my second equation. So it's equation number 2. Now we're ready to solve this. Okay, we have our 2 equations, and again, I'll stick to the elimination method for this one, although in one of the later examples for this lesson number 6, I'll actually end up using substitution. Okay, but let's stack the equations. So we got x plus y is equal to 50, and then I would have 22x plus 16y is equal to 900. Now, if you add or subtract them right now, you're not going to eliminate any of the variables. So if I want to eliminate x or y, you have 2 choices. If you want to eliminate x, I'd multiply both sides of the equation by 22 and then subtract. If you want to eliminate y, you'd multiply both sides of the equation by 16 and then you'd subtract those 2 equations. I'm going to eliminate x. So I'll multiply both the equations by 22, which means you got to apply that 22 to the x, the y, and the 50. So if I do that, you would then have 22x plus 22y would be equal to 22 times 50 is 1100. And then the second equation, you'd have 22x plus 16 times y is equal to 900. And to eliminate x, we're going to subtract both these equations. I'll put the bottom equation in bracket just to remind me that I need to apply this negative to all 3 terms. 22x minus 22x is 0. 22y minus 6y would be plus 6y. And then 1100 minus 900 would be 200. To get y by itself, we're going to divide, because we've got the 0 here. So we can just divide now. So divide both sides of the equation by 6. Divide 6, divide 6. The 6's would cancel off. And then I would get my y value is equal to, and we're just going to write it down as a decimal number. So the y value would be 33.3 kilograms. Once you have the value of y to get the other variable, sub it into equation 1 or equation 2 and solve for x. Always sub it into the equation that's easier to deal with, and that is clearly equation number 1. So I'm going to sub y is equal to 33.3 into equation number 1. So that's going to be x plus y is equal to 50. And we're going to replace 33.3 with x. So then I would have 33.3 plus y is equal to 50. And then to get y by itself, I'm going to subtract 33.3 from both sides. Subtract 33.3. And that would leave me with the mass of the Brazil nuts, which would be, wait a second, I messed that up. We're solving for x, right? Whoops. Yeah, we're plugging in y. Let's fix that quickly. little lapse in my concentration here. Yeah, we're going to replace y with 33.3. Okay, so then that would be x plus 33.3. You're going to get the same number, is equal to 50. And then to get x by itself, we're going to subtract 33.3, subtract 33.3, and then I would get x is equal to 16.7 kilograms. And we'll box that answer. Okay, let's go to the second example now. So this one's more of a chemistry question. I mean, I would say more of a chemistry question than a math question, but you need to be able to do the math to actually deal with the chemistry. Okay, so it says Earl the chemist has to make 180 milliliters of 60% hydrochloric acid. Okay, I just want to do a little bit of an illustration to show you what this means. Okay, 60% hydrochloric acid. So I'm just going to draw a beaker just to show my solution. So here's a little beaker. Now, what 60% hydrochloric acid means is typically the hydrochloric acid, which might be like a solid, is dissolved in water and you stir it together and then you get an aqueous solution of hydrochloric acid. So if I were to draw a picture of what this would look like, if you had like 100% of your solution, 60% of it's going to be hydrochloric acid. So I'm just going to sketch this on the board here, or not on the board, on the screen. Okay, so we'll let this red represent the acid. So we'll say this is 60%. And we're going to abbreviate hydrochloric acid with HCl. Okay, so you have 60% hydrochloric acid, and then the remainder of the solution would be water. So I'll try to make it so it's roughly about 40% here. Okay, so we'd have 40% of H2O. And this total amount of the 60, so again, the 60% hydrochloric acid means you'd have 60% hydrochloric acid and 40% water, and it tells me that there's 180 milliliters of this. Now, to get this solution, we have to mix a couple of different bottles together. So one bottle, we have 1 liter of 45% hydrochloric acid solution. So I'll sketch what that would look like. So this would be, again, draw like a beaker. Okay, 45% hydrochloric acid solution. So you have a little bit left. A little bit less, I should say. Okay, so you've got 45% HCl. Now, this solution would have more water in it. So if it has 45% hydrochloric acid, it would have 55% of water. Now, we're going to mix this with a different bottle. So this bottle has 70% of hydrochloric acid. We'll still draw my next one. So let's put this a little bit higher. 70% HCl. And this would be like 30% water. Okay, so what we're going to do here is we're going to mix these two solutions. Okay, so we're going to combine these two. So these are the ones we're going to mix. Mix these two solutions together, and then we're going to get this solution I want at the end, which is 180 milliliters of 60% hydrochloric acid. Okay, so I'm combining this beaker and this beaker to get the very top one. Now, what the problem wants is it says how many milliliters of each solution are mixed to give you 60% hydrochloric acid. So the two things I'm trying to figure out here is how much solution, what's the volume of solution we would have in this beaker. So we'll call that X. And we also want to know how much solution of this 70% hydrochloric acid do we have. So we want to mix X and Y together to get 180 milliliters. Okay, so let's identify those variables now. So again, that's what we're trying to figure out. We're trying to figure out the amount of this solution, the amount of that solution that are going to be mixed together to give you this one at the end. Okay, so we'll say let X be, we'll say the volume of 45% HCl solution. And we're going to let Y be the volume of the 70% solution. All right. Okay, so let's write down first of all our total amount equation. So we'll say, I'll say volume of solution equation. So when I say volume of solution, that's going to be both the acid and the water. Okay, this one's pretty simple. So what's the volume of solution? It's the volume of solution in this beaker, the 45% hydrochloric acid, which is X, plus the volume of solution in this beaker, which is a 70% hydrochloric acid, which is Y. X plus Y must be equal to 180 because you're trying to obtain 180 milliliters of 60% hydrochloric acid solution. So your first equation would be X plus Y is equal to 180. And we'll go ahead and box that. And if I box that equation, I would get, well, it's just not get. We're just going to label it as equation number 1. Okay, now we need another equation. The other equation I'm going to write is going to be based on the amount of acid in each of these beakers here, okay, as opposed to like how much total solution there is. So the first thing I'm going to do is I'm going to figure out how much acid, so your acid would be, I'll just kind of like highlight it in red, how much acid is in each one of these beakers, and we're going to write an equation based on the amount of acid. Okay, so let's figure out how much total acid is in this beaker at the very end. Okay, so we'll say amount of acid in the mixed beaker well, 60% of 180 milliliters is acid. Okay, is acid in that beaker. When you find a percentage of a number, we can take that percentage and convert it to a decimal. So that'd be 0.60 and then multiply by 180 milliliters. That's 2/3 of 180. 2/3 of 180 would be, oh, sorry, it's not 2/3. 2/3 would be 66.6 repeating percent. 0.6 of 180 would be 108. Okay, we're going to use this number in a moment. Now, I'm going to write another equation based on the amount of acid in each beaker. Okay, so we look at this beaker right here. How much of the beaker would be acid? It would be 45% of the total volume, which is X. So 45% of X would be 0.45 times X. Okay, 0.45 times X. Now we're mixing it, okay? So we're combining it with this beaker at the bottom. How much acid is in this beaker? Well, it would be 70% of Y, which is the total amount of volume in that beaker. 70% of Y, we could write down as a decimal, 0.70 Y. And we know that if we combine the acid in this beaker and the acid in that beaker, it needs to add to give me 108. Okay, because that's the amount of acid, the total amount of acid in this final beaker. Okay, so we're going to box this equation, and we're going to call that one equation number 2. Okay, now we're ready to solve the systems. Let's stack these two equations. So we're going to have x plus y is equal to 180. And then we would have 0.45x plus 0.70y is equal to 108. Okay, right now, adding or subtracting is not going to eliminate any of the variables. So once again, all we have to do is multiply one of the equations by a number, which is just the top equation is the easier one to do. So depending on which variable you want to eliminate, if you want to eliminate x, you'd multiply by 0.45. If you want to eliminate y, you'd multiply by 0.70. So once again, I'll eliminate x. So I'll multiply by 0.45. So this 0.45 has to go to the x, the y, and it has to go to the 180. Okay, so let's rewrite these equations now. So then it would be 0.45x. Actually, let's do it just in a different spot here. Okay, let's bring it up. Okay, I'm going to bring my equations up here. Okay, so you'd have 0.45x plus 0.70y is equal to, okay, 0.45 times 180 would be 81. And then the second equation is 0.45x. Oh, sorry, this should be 0.45 up here. Yeah, so this first equation, 0.45 times x is 0.45x, 0.45 times y is 0.45y, and then 0.45 times 180 is 81. Okay, second equation is 0.45x plus 0.70y would be equal to 108. To eliminate x, we're going to subtract these two equations. So 0.45x minus 0.45x would be 0. And then you'd have 0.45 minus 0.70 is actually going to be a negative number. So that would be negative 0.25y. And then 81 minus 108 is also a negative number, which is negative 27. To get y by itself now, you just need to divide both sides of the equation by the coefficient in front of y. So that's 0.25 divided by negative 0.25 divided by negative 0.25, and then negative 27 divided by 0.25, and then I would get my volume, y, would be equal to 108 milliliters. So that's how much the total volume of this second beaker here, or this beaker at the very bottom. Now, to get the amount of total solution in the first beaker I'm mixing, we're going to sub y equals 108 into the easier equation. The easier equation is equation 1. So if I do that, your equation is x plus y is equal to 180. And we're going to replace y with 180. So this would be x plus 108 is equal to 180. And then let's get x by itself. So we do that by subtracting 108, by subtracting 108. And this leaves me with the total volume of solution in this beaker that includes both the acid and includes the water. And that's X would be equal to 72 milliliters. This one is for sure more tricky than the very top one, because for this one here, you need to understand what it means to have like a specific concentration of a solution. All right, so we'll stop the lesson here, and the problems you can complete to practice this would be starting on page 651 and do numbers 1 through 4, but you can omit 3B. And I'll talk to you in the next lesson, which is the final one, where we deal with distance problem.